Hello, Everett. I wanted to make this quick video to show you the process of setting up the solution I did. So first of all, just make sure that these are the versions that we're working for because I found some packages that weren't completely working. So just make sure these ones are correct. Then we just do npm install in the folder I created in Ganache blockchain. This is the project. As you can see, it had the client that already had it, the server, and I added this folder that is gonna deploy the contracts, is gonna run them, and is gonna test them. And oh, by the way, you need Ganache client. You can install it on Windows or Mac. That's for just testing, local testing, and then for actual testing would be Ropsten. So I'll come to that later. The only thing you need to do, well, I guess in the main project, since it has a package JSON and in the client, and additionally to the Ganache blockchain folder, you just do npm install, assuming that you have the correct version of the Node.js. So then third step to continue with this is to create a env file, which is gonna have all the keys that we need, mainly these two, the private key of the address that is gonna deploy the contract on the blockchain, in this case Ropsten, for testing, and the Infura private key. So you need an Infura account, and then get the key of the project. I think that's pretty much enough, and because after that the configuration sets as this. I can show you. So this is the endpoint, I think, for setting up the wallet and making the deployment of the contract with your private key of the address. I'm gonna do that actually after this. After moving on, the fourth step is running the tests. For that, I am using just Ganache, so you can install it and set it up. Just make sure that truffle configuration is targeting to this localhost port that's shown here as well. I can show you. So this is for truffle, just for local testing. So this is for running these file that I created to make sure that all the what we want the smart contract to do would pass. So these are very simple testing, and for example, at the end I made some assertions checking that after the minting, I would get the same kind of output in terms of the balance of Ether for each, for both the user and the owner of the contract. So you can check it out here with more detail if you want. But overall, yeah, it passes. I can even do it right now. Running truffle tests will take, if it is correctly set up with a Nash, it should go and compile, deploy locally these smart contracts and test those transactions. So at the end, we end up that there is an increase of the owner Ether, since there is a flat fee, right, that we are paying it each time that anybody calls to the Divilia token, and there is a reduction of Ether in the account that called the contract, and you can see those details here. I ended up actually concluding, as a conclusion, I kind of acknowledged the fact that minting it with the ERC721 token means that the fees necessary to execute those opcodes are around $10 plus the $3 of the fee. It gets into around $15 value that the user needs to pay for the transaction, and we will see that later. I already set up these addresses, but just to let you know, this is the way I do it. I created this account called owner of contract Divilia. It has some Ether. It needs some Ether for you to be able to deploy the contract. Something I forgot to mention, as you must know, we have to run npm run dev in order to test the application locally. So I'm gonna do that here. So we have it here, the application running already, and now I'm gonna proceed to deploy the contract on the blockchain. In this case, Ropsten. Now I'm gonna get the address, private key from MetaMask, and in this case, from this address, I need once that is done, we just need to run this command in the Ganache folder. We just need to do truffle migrate reset network equals to Ropsten, and this will initiate the migration of these smart contracts with the setup of the address that is gonna deploy the contract, and it's gonna be the owner, and it's gonna get all the fees from all the interactions of other users. So once that the address is deployed, the smart contract is deployed. Once the smart contract is deployed, now we can interact with the application. So we would need, as I said already, both accounts, the owner of the account and deploying the smart contract, we need some Ether, and the account that is gonna be the minting will require some Ether as well. So I'm gonna use this account. I already previously did like a minting, so I have already an asset. I'm gonna do it again and show you the workflow of how this application solution work. So I'm gonna create a new image here. Something to mention here is that I added an extra logic that will save this image in IPFS. So I'm gonna do this testing too. So whenever this is successful, it also would have created an IPFS path and storage of this image. So I can go to it. I'm gonna select it as collectible. You will see the path of the IPFS storage. And this is the path. So what I'm gonna do actually is take this path and send it as unique token URI on the minting function. As you can see, this is the IPFS storage where the image resides. So this is gonna be the input for the smart contract. This is gonna take it as unique, so it cannot be repeated. If you try to do it twice with this same string, will give you an error. That's how I programmed the smart contract to work. So anyway, now I'm gonna try to mint it. Something to consider right now that I discovered as well is that the minting fees are around $12 actually, plus the $3 flat that the Devilia address is gonna get for each minting. It seems like the overall procedures that the ERC 721 standard need, it needs though that high amount of processing that translate into around $12 for minting. I don't know if that's accurate, but that's what I got from the tests. But I mean, that's for further research. But anyway, I'm gonna confirm it, and then it will require some time. I put a loading here. Once that is done, it will show us the transaction receipt. Okay, so we got the minting transaction hash and the confirmation here, so you can check it out in the scanner, in the Ether scanner here. Oh, by the way, you can check the contract address too. I put all the logs here, so you just have to do F12 and you can see the Devilia contract address on Etherscan, and you'll see that the owner is the same address that deployed it here. And then you will see that this owner will be getting incoming transactions, incoming Ether because of each transaction that other accounts are doing. So this is the confirmation of the transaction. One second. So as you can see, this is the confirmation of the transaction that uses ERC71 token. And then you can see from the contract that it has been executing some transactions already, and actually it holds already some external tokens. You can check it out here. There are already 2 assets here that have been created from a previous transaction that I did, and this one that just happened 2 minutes ago. So these are the tokens and the IDs of each token. So these ones are the ones that actually kind of encompass the unique token URI of the IPFS path. And yeah, you can check it out as you keep adding more and more tokens. Last thing I wanna show you to make sure that the process was completed and you actually have and own your own token is on MetaMask we can import these. This wasn't actually here. I imported it. I mean, even if the address got this asset, you cannot see it unless you add it here as a new token. You add the contract address, which I printed out here. So you just need to add it as a new token here with the contract address. But I already added, so it will usually show you the name of the token, which is this one, Debilia NFT. And it will initially, if you didn't have any asset, it will show you that you just have zero Debilia NFT. So yeah, I hope that you can set it up and run it properly. Let me know if you had some problems. Make sure sometimes to just reload the page to make sure that MetaMask is connected with the right address. And yeah, that was the solution.